Here we go. So 3.6D square and cube root function attributes and transformations. All right. All year we would talk about functions, right? Linear, quadratic, log, exponential, rational, all these functions, right? And we've done the same thing with every single function. What's the domain? What's the range? What's your intercept? Where is it increasing? Where is it decreasing? Right? Over and over and over. Guess what? It's going to be the same thing here, except instead of all the other functions, we're just analyzing the last ones here, okay? So we're going to be looking at the square and cube root functions, our root functions or our radical functions, okay? So if it feels like I'm going fast, it's because I feel like it's something that we should be okay with. Does it make sense? All right, so square root functions, we're going to start off with. Here is the square root function, okay? The square root function is the inverse of the quadratic function with a domain restriction, okay? Meaning that it can't be the full inverse, because if it was, then it wouldn't be a function, because it would be a sideways parabola, right? And it would fail the vertical line test. That's why we have a restriction, okay? So we're going to look at our table representation. When you look at the table representation for the parent function, notice that your x values are your smallest perfect squares, yeah? 0, 1, 4, 9, okay? Those are our smallest perfect squares. That's why they start our table. All the other numbers are possible. It's just that they don't give us pretty numbers, okay? Our function is f of x equals the square root of x only when x is greater than or equal to 0. That's because no negatives underneath the square root. Okay. Next, we're going to look at our graph and analyze the parent function. When we look at the graph, you're reading from left to right. From left to right, what is this function doing? Increasing. So the function is increasing. Then from left to right, we also can analyze our domain. Our domain starts at 0 and continues to positive infinity. So 0 to positive infinity. This is our inequality. This is our interval. So on the inequality, it's just saying that x's are greater than or equal to 0. Is that true? Yes. Looking at my range, ranges from bottom to top. We start at 0 and then we keep going to positive infinity. So we're 0 to infinity on the range, which means that our y values are greater than or equal to 0. Okay? Your x-intercept is where do you cross the x-axis? Your y-intercept, where do you cross the y-axis? So when we look here, they both happen at 0, 0. Okay? At this point, those should be things that you are very confident in doing when looking at a graph. Yes, describing increasing, decreasing domain, range, and intercepts. Got it? All right. So the first thing we're going to do is we're going to talk about being able to do a quick sketch of a graph. Okay? Because sometimes, do you always have a calculator accessible? No. So you need to be comfortable with creating a graph by using a table. Okay? So here we have f of x equals the square root of x minus 1. So when you're creating the table, you want to keep in mind, what are your parent function values? What are your parent function x's? 0, 1, 4, and 9, right? Now, we're going to be making new y's because this isn't quite exactly our parent function. It is f of x equals the square root of x minus 1. So our y's equal the square root of x minus 1. So what's the square root of 0? 0. Well, 0 minus 1 is negative 1. Square root of 1. 1 minus 1 is square root of 4. 2 minus 1 is square root of 9. 3 minus 1 is 2. We did it. Okay? So now we're going to go ahead and graph it. Pretend that these are all the straightest lines you've ever seen. Okay? So we're going to go 0, negative 1. 1, 0. 4, 1. 9, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. Bam. And I'm going to connect them. And there is my square root. Okay. So if I'm looking at the square root, can I identify the domain? Yes. What is my domain? Domain.
Oh.
0 to positive infinity. 0 to positive infinity. Your x's?
Is the y's. Oh.
Which means that my x values have to be greater than or equal to 0. My range, where does my range start? There we go. We start at -1 and we go to positive infinity. So this tells you that my y values have to be greater than or equal to -1. Okay, and notice that we're using brackets and equal to because it's defined here, right? It's not an asymptote. I have a point there, right? Okay, how do we feel about simple graphs and finding the domain and range? Doable? All right, let's talk about simple graphs and finding the x and y intercept. Okay, so again, when I'm looking here, it's just the square root of x. So I want to think about my parent function, right? What is my parent function doing? Well, my x's are 0, 1, 4, and 9. My new y's are going to come from the square root of x minus 3. So what are my new y values? Mm-hmm. 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 And 0. Okay. So I'm going to do a little quick sketch here. Okay, that was better. If you don't see the progress, then you're just in denial. It's the world's straightest line. I've already told you this. Those are perfectly straight lines. Pretend that I went through that point. Okay. Cool. All right. Can you tell from our graph that we have what our x and y intercepts are?
Yes.
What's our x-intercept? 9, 0. I knew we were saying the right numbers. And our y-intercept is 0, -3. Okay. Yes, no, maybe so. Simple graphs and finding. Yeah. All right. So now we're going to just review graphing in the calculator. Okay. Sometimes when we do have the calculator, we're like, you know what? I'm going to graph this in my calculator, right? No, graphing calculator. All right. So I'm going to pull up my graphing calculator. I'm going to clear it because, you know, who knows what I've been doing on it. Okay. So we're going to put in y equals. So I go to y equals and we're typing in 2 minus the square root of x. So we went to our graph and we're putting in 2 minus the square root of x. Second square. All right. So when we graph, what do you notice is happening now to our square root function? It is decreasing, right? It is now going down. Okay. All right. So it's asking us to find the maximum and minimum values over this interval. Okay. So it's asking us to find the max and min values, not your max and min point, but the values. And so because our function is either always increasing or decreasing, that means that you're analyzing the end behaviors. So what do I get at f of 1? What do I get at f of 6? Well, on our calculator, there's a couple ways to look at this. You either can look at the table or you can press trace and type in the value you want. So I press trace I type 1, enter, and it says 1 is 1. You don't say.
How do you use the graph on our calculator?
What do you mean? You go to y equals and put in 2 minus the square root of x.
And I get that, and I put, you didn't, figure out the calculator first. Oh.
Okay, I'm gonna do 6, hit enter, and it says the value of 6, I'm gonna round it to negative 4/500. Okay, so you can trace the graph, and then your other option that you can always fall back on is to look at the what? The table. So second graph it. And I can also go and see that 1 is what? 1. 6 is what? This. Okay. Okay. Now, what's good about trace is that what if you don't have whole numbers? Are your whole numbers going to easily appear on the graph, on your table? No. But on the trace, I can type in 0.5. I can be like, oh, I want to know what is 1.5. So trace 1.5, and it'll tell me the value of 1.5.
And that's all it is to do for that.
Okay. And then you're just saying what's your max value and what's your min value. So your values refer to your output, your y, right? So my max value is 1. And my min value is negative 4,500. How do you feel about analyzing a graph to find max and min on an interval?
I would go to the.
Easy. Exactly. Perfect. But it's asking for the value. It's not saying where it's at, because obviously you know where it's at, but it wants to know what is the value of the max and the min. Okay. All right. So moving on. So we're gonna